Hello, we're Team Nuts and Bolts, and this is our solution to road construction, roadbots.
Road construction is time intensive due to labor and environmental constraints. We are developing an automated system to construct roads under all reasonable conditions. Large construction projects frequently experience delays with nearly 98% facing schedule setbacks and 80% exceeding budget. At the same time, U.S. road infrastructure received a D-plus rating with 39% of major roads in poor or mediocre condition. These conditions cost the average driver over $1,400 per year in vehicle operating cost and lost time. Although safety measures have improved, nearly 60% of highway worker fatalities involve workers being struck by vehicles, and night construction increases those risks. Our team's goal is to address both inefficiency and safety concerns by developing an autonomous robotic swarm capable of constructing roads continuously under reasonable environmental conditions.
Our robot system consists of 4 autonomous robots working as a coordinated swarm. Terra is a land grading robot responsible for preparing and correcting roadway elevation and slope. Gravaz is the material distribution robot that transports heated asphalt or gravel and evenly distributes it across the work zone. Since Team Nuts and Bolts robots are able to work around the clock, more projects are able to finish on time, helping to improve the overall conditions of the highway system. Smooth Operator is a compaction robot that ensures the material reaches at least 95% density and that no gap remain between passes. Finally, the SV9000 is the aerial supervisor drone responsible for monitoring progress, enforcing geofencing, detecting safety hazards, and coordinating subordinate bots. Terra is the autonomous land grading robot responsible for preparing the roadway surface before material placement and correcting the surface after gravel is distributed. The robot has a replaceable moldboard blade which is controlled by servo motors to maintain precise slope control. Terra uses front and rear sensors to detect obstacles and to stay within the geo-fenced work zone. Terra communicates directly with the supervisor drone and other bots to correct grading issues before material distribution begins.
Gravaz is the autonomous material distribution bot responsible for transporting and pouring gravel or asphalt during roadway construction. The robot contains a 30-ton heated chamber that maintains asphalt between 220 and 290 degrees Fahrenheit to ensure optimal pouring temperature. A temperature sensor continuously monitors the chamber to maintain proper thermal conditions. The chamber is lifted using linear actuators, allowing material to flow through a controlled dump gate. An internal agitator and auger system ensures consistent material flow during discharge. A weight sensor detects when the chamber drops below 40% capacity, allowing automated refill scheduling without halting operations. At the rear, a spreader bar and compactor bar ensures the material is distributed to the proper roadway width before the smooth operator performs final compaction.
Smooth Operator is the autonomous compaction bot responsible for the steamrolling phase of road construction. The robot features a dual steel drum system mounted on a sloped central chassis to apply consistent downward force across the roadway surface. 2 forward-facing visual sensors monitor the work zone. One ensures that no uncompacted gaps wider than 5 centimeters remain between passes, and the other detects obstacles entering the work area. A speed sensor ensures the robot maintains travel velocity within plus or minus 10% of the target speed. An onboard density sensor tests the road surface to make sure it meets at least 95% of the specified density. The large chassis allows for an integration of a 400 kilowatt battery system, providing approximately 6 hours of continuous autonomous operation.
The SV9000 is the aerial supervisor drone responsible for oversight, safety, enforcement, and system coordination across all ground bots. The drone maintains communication with each robot via wireless connectivity and continuously verifies geofence compliance. If any bot exits the designated work zone, corrective action is initiated. Using downward-facing LiDAR, the drone scans the roadway surface and generates a point cloud profile of the working layer. It creates a line of best fit to measure local deviations while simultaneously comparing the overall field to a reference model. And, if the deviations accept acceptable thresholds, it signals the responsible robot to correct the issue. The drone also uses omnidirectional visual and radar sensors to detect unauthorized personnel or foreign objects entering the work zone. If a person is detected, it immediately halts all operations. The drone operates within FAA altitude limits, remaining below 400 feet, and has a removable battery system for rapid battery changeouts to get the drone back in service.
Current products and recommendations suggest ways of improving the safety of the work zone sites, including use of temporary traffic control devices like signs and cones. However, these solutions still require workers to be in the risk zones of construction sites. Work zone safety with intrusion alarms can alert workers of deadly hazards, but they fail with false alarms, transmission lags, and the alert can be masked by general construction noise and loud diesel engines on site. Team Nuts and Bolts robots remove workers from the construction zone during the majority of the work. The quality of the work is continuously measured, allowing for longer lasting finished products that exceed the highest of specifications, thus further reducing the need for workers in a dangerous work zone.
Our project demonstrates a fully integrated autonomous road construction system composed of 4 specialized robots working collaboratively as a coordinated swarm. Each robot fulfills a distinct engineering function: precision grading within plus or minus 0.25 degrees, controlled material distribution, compaction achieved at least 95% density, and aerial oversight ensuring safety and quality verification. By combining automation, real-time sensing, and coordinated control, the system reduces worker exposure at high-risk traffic environments while increased operational efficiency through continuous 24-hour capability. Overall, this solution addresses both the technical performance challenges and the safety concerns currently facing modern road construction.